get started. Um, so, first of all, thank you very much for joining in. And in so, we thought of taking this kind of a topic because, like in the previous times, we were talking more about the technical stuff and how to build models, how to train models, those kind of stuff. And we thought like GDG people when they talk to me, they told me that we should focus on something uh, that is very relevant in these days, but uh, which can be digested by not only the high tech people but even the designers and all the other people who may need to uh, like contribute to machine learning pipeline. So this topic, I think, how we can build responsible AI, like when we develop AI system, how can we be responsible in developing these things. So today I'm going to talk a little bit about these things, maybe just briefly go through some of the tools that are available right now, and how to think and how we can create like mental models developing machine learning problems. So, if you were following any of the news, I think you may have come across so many articles in prestigious newspapers or journals about AI being racist, or AI being evil, or AI doing some bad things, right? Right, like even the journals like Nature, the New York Times, MIT Technology Review. So all these places, like people were telling that there were so many issues with models. So as ML practitioners, or as people who are working with machine learning projects, I think you might need to tackle these issues someday. So so uh, so this talk is basically about how to think a little bit about this aspect. I know like people are like thinking mostly on the technology side, like what is the best algorithm to use and how to train your model to get the best accuracy. So those are the things like mostly people are focusing on. But today I'm just going to tell you that maybe you should pay more attention to these areas as well, uh, because uh, we are humans, right? And we build these systems for humans. You have to understand that we are building these systems for humans. And of course humans have a bad reputation, or a bad history about taking decisions which are not in line with everyone. Of course you can't satisfy everyone, but there should be some minimum standards that everybody should be equally treated, uh, things like that. So in this session we are going to look at some tools that we can use to uh, maybe mitigate some of the issues like biases that machine learning models might be showing, because it's not the algorithm which is evil. It's not the algorithm, or the even the person who is developing the algorithm is giving their bias. But as humans, like and Google has some principles to overcome these issues. Like for example, it should be socially beneficial, and it shouldn't have kind of a bias towards a particular set of people, or a particular a group. And the privacy should be there. Like you have to think about data privacy, because when you train, or when you develop models, privacy is something that could come into the picture, because you're using data from somebody's, like maybe you are using somebody else's personal data. So how can you be sure to have privacy on those data and accountability? So those are some of the principles that Google have introduced when you building a machine learning project. So as I said earlier, like it's not the machine learning model or the algorithm or the person who is adding the bias, but as humans, I mean, everybody has some bias. Everybody is coming from different backgrounds, different cultures, different belief systems. So there should be some bias inherently, like having inside you. So when you are designing a machine learning pipeline, these are the main things that you do. Like uh, you collect the data and you label the data. You means a human, some human uh, will will decide like what kind of data to collect and what how to label this data, and the models will be built by humans, and they will be evaluated uh, by humans. By humans means they are the ones who decide which metrics to use to evaluate the models. And when the predictions are generated, usually you see like some nuances in these models based on the person's decisions in the previous steps. So it's not the algorithm which is evil, but sometimes the underlying patterns of the data might show some disparity, which may not be uh, like not people might not have done it by like they didn't want to do that, but sometimes it happens, things happens like that way. So if I give you an example, recently I think Facebook has mistakenly classified some people as primates, right? So based on the maybe the skin color or the facial features, they have classified them as primates, which was not good. I mean, for those particular people. And there was an issue like in the recent, I think last few weeks, that was there. So I don't think it was like people. I mean, Facebook did it intentionally, but think that can those are the things that can happen in AI projects. So these are some steps that in order to mitigate those issues, what kind of things that we can do. And as I said earlier, like human perception drives like all these facets of artificial intelligence, because it's humans who are choosing the data sources. It's humans who are determining the evolution metrics, like how to evaluate the model. And then again, it's the humans who are using the predicted results. So there can be some places where not everybody will like the outputs. So in a typical machine learning workflow, uh, when you're doing it responsibly, you have to first identify, like when you're defining the problem, uh, you may need to think, who is this ML system built for? Like what kind of people, like who will be the end users of this product, and what are their beliefs, or what might go wrong in different scenarios or with different outputs. And uh, and also, is ML a good fit for this problem? Because there could be some problems you may not need to use ML just for the sake of using ML. uh, and in some areas, like if there are a lot of sensitive things are there, maybe uh, you could avoid using ML and come up with a different solution as well. So you may need to first consider whether you need to do it with ML, or if you want to do it with ML, then who you are going to build this system for. And then when you're constructing the data and preparing the data, you have to understand the real world and human biases in the data set. Like for example, I can give you this example. So this was a very famous example given in different talks actually. So this result is from the toxicity data set, which was from 2017. And uh, uh, and I'll tell you the story behind this, because nobody was talking about this story, because I think not many people know the story behind this problem. uh, because this data set was labeled here in Sri Lanka, right? uh, like few years ago, like 4 5 years ago, uh, people who are from this culture, like people who are from Sri Lanka, and I think maybe some people from India, like it's a in this region. So usually when it comes to this region, the word gay may be used for offensive word, like used as offensive word, right? you don't I mean, it's kind of a taboo area to talk about, so people will use it as as to offend someone, or to bully someone. So so obviously when they are labeling it, when the people who are from this region, when they are labeling statements, sentences with this particular word, uh, they might have given a label which saying that this sentence is toxic, right? And but when you are evaluating these sentences in, let's say, a country like US, for them it's not toxic, it's something like somebody's like choice. So they don't consider this as toxic as the people in this region. So for them this is an issue. So they says that this second sentence, so that the since the label data says that this particular word has some toxicity, the system has given an output saying that this particular sentence is uh, 0.86. That means 86% sure that it's a toxic comment. But for them, they couldn't understand. Like they don't consider this as a toxic sentence, while I'm straight is just 4% toxic, which means it's not toxic at all. And similarly, uh, different to this case, if you think about the N word, which is an offensive word, that's why I'm not saying it. The N word, which is being used in Western countries, especially like in the US, they use it to bully or offend some people with darker skin. So, but if you think about this region, like probably in Sri Lanka or even in India, like uh, you don't consider, like you don't bully people based on the skin color. I mean, rarely there could be sometimes, but like if I tell you a example in Sinhala, even like in my old days, like I have seen people were called Kalua, Kaluaya, Kalumalli. Like it's not offensive. Like we call that, we use that word to give our friendliness. It's not a offensive thing, and people love it. Like when you use sometimes when you use the uh, skin color just uh, to call him, like sometimes I mean, it's not a offensive thing. But if you consider that in a country like US, probably that's offensive, because they had this issue with the color of the skin. So that's why when you are developing or creating a data set, you have to think about those aspects as well. When you are labeling a data set, sometimes the culture or the biases that you have in a particular country may not be valid in another country, or to not only a country, but maybe to a different sets of people, different people who believe in different things. So that's why when you are defining your problem, you have to think who are the end users of your project or your system. uh, and then when you're building the model, you need to think more about how to interpret your model. And interpret means based on what criteria the model has taken a certain decision or certain prediction. And also the privacy, as I said earlier, privacy will be another big thing that might come in the future, because uh, especially in European Union, or even in other Western countries, they are considered mostly about their privacy, data privacy, their personal data. So so that's why even libraries like TensorFlow have different tools to address these issues. Like for example, they have something called federated learning, and they have another library called TF privacy, where you can use those tools to address those issues. And when you are evaluating, you need to consider what kind of metrics to use to evaluate your model, because it's not just the overall accuracy, or the overall model performance that you need to consider, but you need to look at how different slices, or how different like different like let's say, for example, if you have a model with male and female, and maybe people from different colors, like in your data set. You need to slice the data and see how well the model is performing on different slices. Like for example, if you take how well it works for white skinned males versus how well it works for black skinned females. So if they are both like working equally well, that means your model is not just performing well, but also it's fair to the the other people as well. But if there's a disparity, if the model is working very good for let's say white skinned males, but not working well for black skinned females, that means you have, I mean, your model might have a overall, I mean, good overall performance, but the model might not be doing a fair job, right? So you need to do that evaluation part as well when you are developing these kind of models. And also, like once you deploy, you need to again like understand what are like who are the people, who are the stakeholders of this model. And then even after deploying, you need to monitor what are the, there could be some differences while running the model in the production. So there are a few tools. So first, I'm going to like tell you a bit about the Whatif tool. It's a tool you can just pip install it, and it will be a useful tool to see your data set, like how it has predicted certain results for certain predictions, how it came to, sorry, certain predictions. And also they have a way to identify performance. You can slice the data, like for example here, you can use different features, like let's say you have a gender, or you have maybe skin color, or whatever it is. You can slice the data and see how the model or models, so in this case we are using two models here. You can see this one and two. So model one and model two, which means we are comparing two models on the fairness basis. So how well these models work and what are the threshold values. So here in this case, if the model predicts something more than zero point 0.5, which means it's going into a one class, and if it's less than zero point 0.5, that means that it goes to the other class. So you can change that value and see how many correct results and incorrect results, and what are the what is the optimum threshold to give a better performance, as well as a good performance for the different slices. Like slices means based on the gender, or based on uh, whatever the feature that's available in the data set. uh, and also you can see, like using the Whatif tool, you can see what kind of features, like how features are affecting the uh, end results. So what are the major factors that a model is considering before making a prediction. So Whatif tool is a pretty handy tool to understand the dynamics of your model. uh, and then so give me a second. And then there's another, so once you know that your model has certain biases or certain issues inside, you can use different techniques to maybe change those stuff. Like for example, remediation is one such thing. So let's see like the comment toxicity classification, which is actually trained on the dataset called civic comments, which is on TensorFlow datasets. And we are going to use a technique called MinDiff to see how we can make the model little bit fair. So model remediation is like when you do model remediation, what it does is it will penalize the disparity between different features. So it changes the distribution a little bit. And when you do that, it will sometimes give a less good result. Like let's say if your first model give you 95%, maybe this the the model with remediation might give a lesser result, but that's the overall performance. But when you compare it with how it has performed on different slices or uh, different fairness indicators, that might give a better result. So how we can use this remediation is like you can simply uh, import mindiff from the remediation model library, and then you have to use your original model which you use to create the initial predictions. And then you need to define your loss, which is here in this case we are using mindiff. And then you have to create the mindiff model with the original model and the mindiff loss function. And then, as you know, like as you do always, you have to compile your model and fit the model on the mindiff dataset, right? Like the dataset that you have created to run the mindiff. uh, Once you do that, so this is uh, one example that as I said, like ran for a civic comment dataset. This is the false positive rate before mindiff. So in this case, like you can see different religions here, and these are real world data sets, and real humans have given these labels, and even the data created by real world, I mean real people. So when you look at this, the last column, it's the religion Muslim, which was incorrectly classified as toxic in most of the cases. And so which means incorrectly classified. It's not always toxic, but when that religion was connected, like people have uh, labeled them as a toxic comment. And because of that, model has picked up that pattern, and it always incorrectly predict that when this uh, region is there, uh, like most of the time it labels it as a toxic comment. And once we do the mindiff, like you might not see a difference here, but uh, like I'll show you the numbers. So here in the earlier case, so the top table is before the mindiff, and the bottom one is after the mindiff. So you can see, like initially, like for example, there were so many numbers, like so many like compared to overall performance. Like certain religions have like very like disparity, like it's a high difference between the correct predictions and incorrect prediction. Means like for example here for Muslim it was 232 percent of the time it's incorrectly classified as toxic. But once you do the mindiff one, the things have like made better. Like it's not that unfair, but still you see some issues. But like if you compare this number, for example here it's 0.036 and down to 0.01, which is a good improvement. So it happens for most of the religions here. So that's how you can do some changes to your model by using these kind of tools and methods. And next, the other important thing is your model has to be transparent, because it's not only a technical person that the model will be used. There can be people who, like the developers and even the users, might want to know what's going inside the model, and what kind of, like, going inside the model means not the technology or the algorithm, but how the data being used, and how the model is performing. So maybe in the future, I don't know, like it might be crucial to know for regulation purposes, maybe even for legal purposes, that how models are doing, and even when a model take a decision, if you want to, if you know, like based on what criteria the model has taken a decision, you have the trust, and you can believe it, you can trust the prediction, and you can go forward with it. Because uh, recently we have seen so many examples where models have been discriminating. It's not the model. Again, I'm saying it's not the model which is discriminating, but based on the data, it has picked up some patterns which are not uh, really good and which are discriminative. So if you know what are the factors that model has been using. Let's say if the model is using maybe certain gender to discriminate for a particular job, then that's, I mean, if you know, like the model is using the gender as a factor to make the prediction, you know that the model, although the overall performance is good, it's not a good fair model to use for a production or the real world situation. So so that's why transparency is important, not only for the developers but also for the users and other people who make decisions out of the models. And in order to do that, there's something called model cards, so which essentially a structured way and more accessible way for anybody to understand about models. So so this is a example of a model card. uh, so in order to create a model card, you can simply use model card toolkit, and then you define, like for example here, the qualitative fields, you have to give those things, like for example the name and other like limitations and other ethical consideration, etc. And then the quantitative fields will be auto generated with the data set that you have trained your model with. uh, so so once you, like for example, you can define the qualitative fields, and then you can create the JSON, like, and then you can convert it to a HTML page using the model card toolkit. So here's an output HTML of a model card, model card, uh, and you can see these are the qualitative metrics, right? Which you have to give. For example, the considerations, the limitations, you have to give that to the model card toolkit, and it will create this nice and standard model card. And these things will be get by the model itself. So because when we are training the model, it knows like what kind of distributions that a training set have and evolution set has. And also quantitative analysis based on different slices, different maybe ethnic groups, or whatever the slices that you have in your data set. So these things can be seen once you develop, I mean, once you create the model card. Uh, and yeah, so responsible AI is an iterative process. It's not that you start and end in one go. You have to go back to the first phase and maybe uh, think again about the biases in your data set, and maybe do some changes to your data set, and then train your model again and evaluate it. So it's an iterative process, not a just a one-time thing. Uh, and it's not linear either, because again, as I said, you have to go through different steps in different times. You might evaluate, and before deploying, if you feel like it's not that fair, I need to change a certain maybe stuff in the data set, or you need to change something on your model, you have to go back and do that change. So it's again not a linear thing as well, linear development as well. So here are some of the stuff, some of the things in responsible AI toolkit. We just talk very briefly about model remediation, fairness indicators, and what if tool, and model card toolkit. But there are tons available that if you are willing to learn or willing to understand more about this area, that you might want to try. Like for example, this People Plus AI guidebook, which is available online, and almost, I mean, all of these uh, tools and libraries are openly available that you can try out. So in different phases, you can use different tools, like the fairness indicators and the what if tool that we saw earlier, it's basically on the evaluation phase. And the model remediation, it goes under the training phase, because once you identify different problems, you can use the remediation tool to method to like retrain your model and come up with a better results. So here's the link to the pair. Pair means people plus AI. That's a team that works really heavily on these areas, like how we can come up with more like better, like more fair and equal technologies for everybody. So I think it's if you're interested in this area, probably you can go to this website and find more information, find more resources. And with that, I think that's I can conclude. Thank you very much. And if you have any questions, feel free to ask.
Hi, Keshan. Thank you so much for taking your time today to do the lab with us. And I hope like the audience learned a lot of things from today's session, and it was great to have you here with us today. Thank you so much once again. And a small note to all our audience today here. I hope you all have seen the quick lab that we have pinned in the chat. So you will be getting 1 month credit from the to do quick labs, and in the when you go to that particular link that we have pinned here, and when you go to the machine learning and artificial intelligence track, you will have three labs to do, and when you enroll and do the you can do the labs, and from we have swags ready for the people who will be doing the most number of labs from this machine learning and artificial intelligence track. Plus, like if everyone does complete like the most number of labs, we will be going ahead and picking the people who have completed the labs at earliest. So you will have 1 month to complete this, but we will be picking the people who have done the most number of labs, or it will be the people who will be completing the most number of labs at earliest. So we just keep an eye on Google Cloud's Sri Lanka page, and we'll be collecting the details of the people who are completing the labs via a form, which we will publish in the Google Cloud Sri Lanka page. Uh, okay, so that's it about. I think if you all have any questions for Keshan, we just missed the Q&A part. If you all have any questions, just put in the Q&A section, and we. Okay, it seems we don't have any questions posed. So I think we can. So if you have any questions or any clarifications, just drop us a message in Google Cloud Sri Lanka Facebook page, and we'll get back to you. And just keep an eye on the form that we'll be publishing for the to collect the information about the people, information about the lab completion progress. So thank you everyone for joining with us today, and we hope to see you in our next event. And have a good night and a good weekend. Thank you, everyone.